In this video, I'm going to go through the hybridization homework questions. The first question that we had to do was show the hybridization of BRF5. Remember, step one is going to be to draw the Lewis diagram. So I'm just going to quickly write step one right here. Okay. And we're going to do the Lewis diagram right here. Decide which atoms are the central atom. Well, Br is the first atom that appears there. 5 fluorines around it. Okay. Count all the valence electrons. Bromine has 7 valence electrons. Fluorine also has 7 valence electrons, but then there's 5 of them, right? So 7 times 5 is 35, plus another 7 is 42. So I have 42 electrons to place. I then bond all the atoms to the central atom. 2 electrons, 4 electrons, 6 electrons, 8 electrons, 10 electrons. 10 electrons placed, that leaves me with 32 electrons left. And then step 4, complete the octets of the surrounding atoms. So these are my surrounding atoms, the fluorines. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so that's 30 electrons, 2 left over. Okay, so if I have 2 leftover electrons and all my surrounding atoms have their octet, it says place any remaining electron pairs on the central atom. So then I'm going to have to place 2 on the bromine right there, and now I've completed the structure. So bromine pentafluoride looks like it has a bromine surrounded by 5 fluorine atoms and then a lone pair on the bromine. So all of that right there just represents step 1 of the hybridization. That's your Lewis diagram. Now step 2 of hybridization says show the valence shell. So step 2, I'm going to show the valence shell of bromine. Okay. And what I need to do for bromine is I need to go look up bromine on the periodic table, and I need to find out which one is its valence shell. So bromine's valence shell is going to be 4s, 2, 4p, 5, right? And fluorine's valence shell is going to be 2s2 and 2p5 as well. Again, recall that there are 5 of these. And the issue that we can see here is that 5 fluorines do not have enough unpaired electrons to bond with bromine. So what I need to do is I need to be thinking about electron promotion, thinking about if there's any unoccupied subshells. And in the 4th energy level, there is an unoccupied subshell. That's the D subshell right here, completely unpopulated. And what I need to do is I need to think about how many electrons should I promote. Well, let's move 1 electron and promote it up here. Okay, great. That electron gets promoted. Now I can make 1, 2, 3 bonds. Well, that's insufficient because I need to make 5 bonds. So I'm going to take another electron and I'm going to promote it to the D subshell. And I look, 1, 2, 3, 4, 5. Now I can make 5 bonds. Okay, and that right there is step 3. That's my electron promotion. Okay, step 4, always we go back right here and we check to see if there's any double bonds or triple bonds. There's not, so I'm not going to do step 4. Step 5 says let's look at the hybridization. Okay, so we hybridize only the central atom and only its occupied orbitals. So which orbitals are occupied? Well, I've got a lone pair in S. I've got unpaired electrons in all of the P's, all 3 P's. And then I've got unpaired electrons in the D from my electron promotion. Great. This is going to be D2sp3, and the shape is going to be octahedral. So I draw out my D2sp3 hybridized orbitals. There's 6 of them. Okay. Place my electrons. Note that one of my hybridized orbitals is going to contain a lone pair, and then I have these 5 unpaired electrons, and that's for bromine. and each one of these is a D2sp3. I'm only going to write it once. Fluorine over here is 2p2s. Okay, and we can see where the overlap is going to happen. And remember, like, let's just recall that there's 5 of these, right? So the 2p orbital is going to overlap with a D2sp3, a p orbital is going to overlap with another D2sp3, so on and so forth. There's going to be 5 overlaps right there. Okay, so how do I draw octahedral? So again, I'm going to put bromine in the middle. And octahedral, recall that it has a square plane. And then it has an orbital up and an orbital down. Okay. In this case, it doesn't really matter where you put the lone pair, but I'm just going to put it on the bottom right here. Then because recall we have a lone pair right here. Then I'm going to surround it with fluorines, okay? And I'm going to recall that the fluorines are all 2p orbitals, okay? So I want my 2 lobes because they're 2p's. And each of those overlaps produces a sigma bond right there, okay? So far, so good. And the final step that I have to do is draw my structural diagram. So I'm going to put my bromine here, and recall I'm going to have fluorine going back, fluorine over here, so that's these 2 fluorines right there. Then I'm going to have fluorine over here, I'm going to have fluorine over here, and I have another fluorine on the top. On the bottom I have my lone pair, and then I just have to state the bond angles, which in octahedral are all 90 degrees. The next homework question that we have to do is PCl5, starting with my Lewis diagram. Which one is the central atom? Clearly it's going to be phosphorus, surrounded by 5 chlorines. Okay, count all the valence electrons. If I look at the top of the column for phosphorus, I see a Roman numeral of 5. If I look at the top of the column on the periodic table for chlorine, I see a Roman numeral of 7. So that means phosphorus has 5 valence electrons, and chlorine has 7 valence electrons, and then we're going to multiply that by 5. Okay, we are looking at 7 times 5 is 35 plus another 5, so it looks like I have 40 electrons to place there. So let's begin. I'm going to bond all the atoms to the central atom. So 1, 2, 3, 4, 5 bonds. Recall that each bond is 2 electrons. So right there I have now placed 10 electrons. Great, 30 electrons left to place. Step 4. Complete the octets of the surrounding atoms by adding electron pairs. Remember, hydrogen's your exception. Hydrogen only wants 2 electrons. But chlorine is not an exception. Chlorine certainly wants 8 electrons around it. So I have to complete its octet. So I add 2, 4, 6, and then plus the 2 bonds, or sorry, the 2 electrons in the bond, that would make 8 electrons right there, right? So I've placed 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 30 electrons have now been placed, and I have no more electrons left to place, so I have sufficiently completed my Lewis diagram. Now I go to step 2, and step 2 is drawing out the valence shells. So we go to fluorine, or rather, not fluorine, phosphorus, apologies. Okay, phosphorus is in the 3rd period, so I have 3s, and I've got 2, and then I've got 3p, 1, 2, 3. Chlorine, and recall there's going to be 5 of these, is also in the 3rd period, so it has 3s. and 3p. Okay. So we have one p orbital that needs to share an electron with another orbital. We see a problem here. It looks like phosphorus only has the capacity to make 3 bonds because it's got 3 unpaired electrons. So we now need to be thinking about electron promotion. We have an empty subshell in the 3D, all over here, just completely unpopulated. And so now I need to think about electron promotion. Well, I can only promote this one over here because we've got an extra one here. So let's promote this one and bring it up here. And let's check to see if that will give us sufficient unpaired electrons to make 5 bonds. 1, 2, 3, 4, 5. Amazing. I can make my 5 bonds with this unpaired electron in the 3p orbital of chlorine. Okay, so that's my step 3. Great. Step 4, clearly see over here, no double or triple bonds. Don't need to do that. Step 5, let's talk about hybridization. Okay. I look at all the occupied orbitals of the central atom. I have S that's occupied, 3 P's that are occupied, and a D that's occupied. So I have S and P and P and P and D, which makes DSP3. DSP3, the geometry there will be trigonal bipyramidal. Okay, great. And so now I do my hybrid orbitals. Each of these are DSP3 hybrid orbitals. And they all have an unpaired electron spin. Chlorine is 3s and 3p. And remember that there's 5 of them, so the overlap will take place as follows. Okay, I'll just kind of sketch this out. We've got overlap here. No, my apologies, wrong overlap. Got carried away. Overlap here, overlap here, overlap here, here, and here. Remember, it happens 5 times because we have 5 different chlorine molecules, 5 different chlorine atoms. Trigonal bipyramidal has a triangular plane in the center. So this is my triangular plane right here. And then it has an orbital coming up and an orbital below. Each of these is going to be overlapped with a chlorine 3p orbital. That's my 3p. I'll just indicate over here. All of these are DSP3s. Each of these resulting in a sigma bond. Okay, final step is to draw out my structure. Okay, and so that's going to be as follows. I have P, I have a chlorine, and a chlorine. That's my triangular plane. And then I have a chlorine coming up and a chlorine coming down. Bond angles. So the chlorine above and below make a 90-degree bond angle with the chlorines on the plane, and these chlorines all on the plane have a bond angle of 120 degrees. The final homework question that we're doing is the hybridization of water. Okay, so I'm going to decide which atom is the central atom here. Okay, so oxygen is going to be my central atom, and I'm going to surround it with hydrogens. All right, count all the valence electrons. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron times 2. So I'll have 8 electrons to place. I bond all atoms to the central atom. Okay, all right, so that means I've got 4 electrons and I have 4 electrons left to place. It says complete the octets of the surrounding atoms by adding electron pairs. Hydrogen is the exception. right? So hydrogen only wants these 2 electrons. Hydrogen only wants these 2 electrons that are in the bond. So I don't have to do step 4 because the surrounding atoms are hydrogens and they only want those 2 electrons. So I move on. Place any remaining electron pairs on the central atom. Okay, so here we go. Got 4 electrons and now I'm at 0. Perfect. So this is my Lewis diagram and this was all step 1. Okay. Step 2 is my valence shell. Okay, and so I have oxygen with a 2s2 and 2p4. Okay, and this is hydrogen right here. I've got a 1s, and let's just do another hydrogen right here because there's not very many, there's only the 2. And as you can see, well, it looks like these can form bonds and no electron promotion is necessary. That's true. I do not need to promote any electrons because there are sufficient orbitals to bond with the hydrogen. So I actually don't need to do step 3. And if I look at it here, I have no double or triple bonds, so I don't even need to do step 4 either. Okay, just to review, I don't have to promote any electrons because I already have enough unpaired electrons to make the number of bonds necessary. So does that mean that I don't hybridize? No. Hybridization still will take place because recall I am still hybridizing the orbitals of the central atom and I'm doing the ones that are occupied, even those with lone pairs. So S has a lone pair, it's hybridized. This P has a lone pair, it's hybridized, occupied, occupied, also hybridized. So this right here is sp3 hybridization, which results in a tetrahedral shape. Okay, and so there, remember that sp3, we get 4 sp3 hybrid orbitals. Right there. Okay, then my hydrogen is going to be here with a 1s and another hydrogen with a 1s. And we can clearly see where the overlap is going to happen here and here. So the 1s is going to overlap with an sp3 and a 1s is going to overlap with an sp3 as well. Okay. Tetrahedral can be drawn as follows. We have oxygen in the middle. Remember, we have 1 coming up, 1 coming to the side. These are on the same plane. This one's coming forward, so I draw it a little bit more exaggerated because it's coming forward out of the page. And this one's behind, so I only draw it like that so you can see it's like tucked behind there. And each of these is an sp3 hybrid orbital. Each of these. 2 of those sp3 hybrid orbitals have lone pairs. All right, and then we also have hydrogens here and hydrogens here. So this is a 1s. Recall they're going to be spherical because the s orbital is spherical. And I'm just going to indicate that these make sigma bonds right here. And for this one, because remember I said these are in the same plane, right? This is just up and down, or up and to the side. These are on the same plane. I do not need a 3D diagram here. I can draw it in the same plane with a 109.5 degree angle between them and my lone pairs like that. Great, thank you for watching.